Cool. Cool. Hi, everybody.
Right, we are Project Golf, and our very liberally interpreted brief was to create a real Guitar Hero system. What we interpreted that as is a completely arbitrary effects processing platform, which would have generated MIDI output, so you could control synthesizers and stuff, but more on that later. So this is what proper effects GUI is now. Guitars are cool, effects are cool, but all of these tiny modular effects, each of which perform one function, need to be grouped together. They're very hard to rearrange, but at the same time, an alternative to this is a software solution such as Guitar Rig here, which allows you to have a linear effects chain of any conceivable kind of effect that's been produced and completely rearrange them in an arbitrary fashion, but you do need your laptop with you. And someone might pour beer on it. But another aspect of the project was that Guitar Hero is sweeping the nation with its intuitive gameplay. I don't play it. But the thing about Guitar Hero is it doesn't teach you how to play guitar, and it's a lot harder than playing guitar if you're a guitarist. But it might be just because your guitar's actually on your t-shirt or really small. So I mean, what we were trying to do was create a digital instrument that would allow you to also learn new songs on the guitar with MIDI capability. So the first part, well, I mean, here's a diagram of the entire system. Take your guitar. We use this embedded microcontroller, which is based on the ARM processor. It's called the mbed, with just an M and a bed. And then the output of that, whether audio or MIDI, would have been sent to some arbitrary destination, whether it's an amplifier, a synthesizer, or your learning tool on the computer. So the first part of the system is the embedded guitar processor, which Scott will talk you through.
So the embedded guitar processor's main goal is to be able to create a virtual effects chain on the computer, like as if you were chaining together real pedals in real space. And so then with that, you'd be able to have this amazing musical control system that will allow you untold possibilities of signal manipulation and signal conversion. And so that was done with the embed, as Rodri said, using a complicated flow diagram, and so that's what the embed looks like right there. That's our system, and so that will allow us to simultaneously analyze MIDI signals as well as create effects processing. We had a lot of difficulties. I won't go into them. They're in a variety of different ways, but we had fixed point, floating point, things like that. And so what we ended up having was more like this than the previous maximum control system. Cool. And so.
Right, now a common thing to do with pedals is to get a bunch of them and then connect them in some form of configuration that produces a cool sound and then tie it down to a physical board. And that's useful because it allows you to carry it with you and you can reproduce this sound whenever you want, say when you're playing a song. But it also has problems. And so we believe that with using our device instead of a conventional pedal board, we can solve some of these problems. But the question is, how do we make this as easy to configure as this? And the answer is through smart design. This interface is centered around the notion of a virtual pedal board, which is essentially an ordered list of pedals. And the user is at liberty to edit the parameters, rearrange the pedals, and add and remove pedals at will. And it works. So I'll just talk you through a couple of the problems that we face during development. And one thing is that normally when you're performing, you want to change your parameters on the fly so that you gain some kind of flexibility while performing. And we were worried that by pre-processing the pedal board, we would lose some of that flexibility. So the solution was simply to allow inputs connected to the embed device to be mapped to specific predefined parameters. In addition, using digital processing hardware, we are bound by the computational cost. So we had to use intelligent software that's realized when to stop, really, and it works.
The learning tool itself wasn't able to be completed entirely due to the lack of capabilities of the embed itself. We reduced what we could, and it was intended to be a set of interactive instructions that would show the user what they need to play, and then it would take the input from the embed and see if they did play it. So that's the sort of interface that GUI interface that we were going for. It would display the tabs, and if it was any more complicated than was able to be seen scrolling by quickly, it would be displayed as a chart above that would be much easier to see.